New project. Okay, and we're going to divide you guys up into two. You can separate. And here are the two projects. They're on that first page here. And so we're going to write them up just like we did before, and then we're going to share. And because some of you are going to do one and some of you are going to do another, you're going to have to be able to explain enough what your project was. So, okay, so here's one. How much air is in the sponge? What is the pore space of this sponge? And we're going to ask you to express it as a % of the total volume. That's project number one. Project number two is going to happen in there, and you're going to be given oil, beakers, hot plates, and popcorn. And the idea, it says here, if you could, we want to read it, but the reason popcorn pops is because the vapor turns to steam, expands, blows open the kernel, and simultaneously cooks the starch, and you have popcorn. So popcorn has to contain water or else it will not pop. So your challenge is find out what % of the original weight is water. Now, when I give the project like this to my students in the first couple weeks of class, they look at me like, but I can tell you, I could give this project to them at the end, and they're like, let's do this. I mean, they're on it because we've been doing it all year, every single week. Let me show you what tools we have. We have rulers, triple beam balances, which you are welcome to bring to your table or take in there to use however you see fit. And also, sometimes it's handy just for measuring. We have some dial and digital caliper. Sometimes it's just handier to measure this way, just faster than holding a ruler. You don't have enough for everybody, so you're going to have to share. And you can do anything you want. You can use beakers with water. Like, all of these tools are available to you to come up with those two answers. Pick a sponge, any sponge. There's two types.
My brain is like a sponge.
Yeah, there are two types of the.
So, and the answers are different for both. Just pick one.
I like blue.
Regular rectangle, right?
Measure and it practice graduate studies. The volume of water that goes into the next watch the drive. Yeah, just count them, and because we know the weight of 100 dried kernels, we can do the math.
All right, I think we have a quorum. So let's talk about what we did. And since we did two different things, it may require a little bit of extra explanation. And then maybe we can just discuss a little bit about the experience of doing that. And maybe we could discuss the interpersonal experience, because when things, not everybody agrees, and sometimes people get frustrated, and you'll find that kids will, like, they get stuck and then they shut down, and then, you know, sometimes people get mad. I mean, there's all sorts of things that happen when you mix it up a little bit. Things, the law of unintended consequences, you know. When you guys did the popcorn, did you take into account that the popcorn was going to absorb oil? It was going to gain weight? Almost none of the kids get this right, because they take the popcorn out and weigh it, and they're not able to account for the fact that it absorbed a substantial amount of oil. So then we have to have the discussion, well, did you really weigh what you think you're weighing? Did you really weigh just the popcorn, or did you weigh the popcorn and all of its absorbed oil? You know, and they're like, I don't know. Like, well, you know, go back and think about that, and then come back and tell me. And they come back like, oh, right. Like, our popcorn actually weighed more, you know. And what they got was, they think that they got like 20%, but actually what they got was the fact that it's 20% heavier. But the fact that they got a number that seemed reasonable, like 20%, even though it actually weighs more. So, you know, they don't think that through. The lesson in this one is that you have the popcorn, the beaker, and the oil, and we're going to call that the system. And you're going to measure the rate or the change in the system. And then they're like, oh, I get it. So that's kind of the takeaway from that. Now, we only had two, but in a big class you'd have a lot more answers. So here we go, drum roll. Final answer for the popcorn. 14%. that is pretty much the target for popcorn manufacturers is 14%. So, how did that happen? You guys were right on, you know, except you were in agreement, but not correct. Or is it possible that this popcorn is actually damper than normal? So, and where do you think, what could possibly account for this error? The most accurate results come from putting some kind of paper towel over the top and then including that paper towel as part of the system so that the oil that's absorbed by the paper towel is also included in the system, so there's none of that. That's one possibility. It absorbs the water, and what happens is, and kids have been like, they totally did it right and they got the wrong answer, and they're kind of unhappy, you know. And what we'll do sometimes is, because we have the luxury of not having some other teacher like saying, hey, let's make sure these guys get to the end of the book, I'll say, all right, let's just do it over, you know. And they'll find out, like, so what they discover is over time, even after you pop it, it gets lighter and lighter because steam is still evaporating, you know. So really it depends on how quickly you do it, or if the thing covers it. Yeah, there's all kinds of variables. So, and the purpose of this project, again, the purpose of all three of these projects is not to get the answer, but to work in teams, problem solve, communicate, and understand error. So, so yeah, 14% is the answer, and pretty much if you repeat it and enough people do it, people hone in on 14%. So, but if you actually just take the popcorn out, it ends up weighing more, and kids cannot understand that. Like, Mr. Weinberg, you said it was going to get lighter. It's like, well, the popcorn is lighter. You just got a bunch of oil in there. So that's the popcorn problem. Okay, what about the sponges? So we had two types of sponges. This is my all-time favorite answer, is a kid takes a sponge like this and just comes along and puts a textbook on it. And here's the sponge. And they just take, here's your part, here's your hole, done, percent, like that. I'm like, dang, dude, that's awesome. Okay, you know, like, you did that in a fraction of the time it took everybody else, and it totally worked. They got about the same answer. So it's like,
Did you have a dry sponge?
He wet the sponge first, right, so we could compress, you know. But, you know, and then another kid seeing that, they like put it in the vise and like really cranked it tight, and they measured it with the calipers, and they got about the right answer. These turn out to be about 92% is what most people get, and for the yellow ones, it's about 87%. So, I mean, that worked out pretty well. So, but I never tell the kids this, ever, okay? The popcorn one is the first one we do, and I tell them the answer, and this is why. So there's a lesson in here. So the lesson we're trying to get to, besides the communication, is let's talk about error. So the lesson in the popcorn one is, I say, okay, the industry standard is 14%. You got 16. What is your error? So, like, if they get an answer that's not right, how wrong are they? Can you quantify your wrongness? Right? And they're like, well, I don't know, I'm off by 2%. Well, what does 2% mean? 2% out of 100 means a lot less than 2% out of 14, right? So then it's like, oh, I get it. So what you need to know is, or what if I'm a 12? So really what we got is 14, which is the actual value, minus your value, the absolute value of, over the original answer, gives you your percent error. So like, oh, absolute value, what is that? How is that useful? Well, it's useful right here because this works if you're over or under. So this is how, like, you try to teach these things and bring them in. So, I say, I see I'm off by 2 out of 14. That's my percent error. So, like, and I give them worksheets on how to calculate percent error and all these different things because I want them to be able to quantify how correct or not their answers are. So that's the lesson for the popcorn problem. And then for the sponge problem, as I say, all right, we have all of this data. Let's say we have 80 and 90 and 92 and 95 and 89, and on average, let's just say our average is 88. We don't have an absolute. So then what we're going to do is say, all right, well, how does your answer compare to the average answer? So let's just say this person got 92, their absolute value is 4 out of 88. That's their percent error. So just teaching them kind of fluency with numbers and understanding what those numbers mean. So anyway, so that's the lesson out of that.